In this video, we're looking at one other problem in your cumulative final exam that you're grading, and it was missed in the videos that I had just made. So the following question says, find the derivative for each of the following. We're finding the derivative of f of x equals x to the fifth plus 1 over x to the sixth minus the square root of x cubed minus e raised to the x squared plus the natural log of x cubed minus e cubed plus cosine of x sine of x. So I notice in here, I want to rewrite this a little bit to help me take the derivative of it. And so let's rewrite f of x. And f of x is equal to x to the fifth plus 1 over x to the sixth could be rewritten as x to the negative 6 minus the square root of x cubed. Let's rewrite that so it doesn't have the radical and that it is in an exponent in rational form. So the square root of x cubed is the same thing as x to the 3/2 powers minus ex squared plus, notice that I have the natural log of x cubed. I can use rules of logs to rewrite this as 3 times the natural log of x minus e cubed plus cosine of x all times sine of x. So finding the derivative of this, derivative of x to the fifth power is the same thing as 5x to the fourth plus the derivative of x raised to the negative 6 power, bringing down our power, we get negative 6. X, subtract 1 from our exponent, so negative 6 minus 1 gives me negative 7. Minus, bringing down my power, derivative of x to the 3/2 is 3/2 times x. So subtracting 1 from 3/2, 3/2 minus 1, or 3/2 minus 2/2 is 1/2. Minus the derivative of e to the x squared. I need to use a chain rule there. And so the derivative of the outer is itself for e to the x squared power, times the derivative of the exponent, which is 2x, plus the derivative of 3 natural log of x is 3 over x, minus the derivative of e cubed is 0. And then the last term in here, the derivative of cosine x times sine x, I need to use my product rule. Derivative of cosine x is negative sine x times the second sine x plus the first, which is cosine of x, times the derivative of sine x, which is cosine x. We can clean this up a little bit. And so we have the derivative of f of x is 5x to the fourth minus 6 divided by x to the seventh minus 3/2. X to the 1/2 power is the same thing as square root of x minus 2x e to the x squared plus 3 over x minus sine x times sine x is sine squared x plus cosine x times cosine x is cosine squared x. So one more question. So use logarithmic differentiation to find the derivative of the following. And our following is y is equal to 2 to the x. And dy dx is equal to 2 to the x natural log of 2. Oh, so I'm sorry, I didn't read that correctly. So use the logarithmic differentiation to show that the derivative of y equals 2 to the x is the following. 2 to the x natural log of 2. Okay, so let's use logarithmic differentiation to show that. So we have y is equal to 2 to the x. So let's take the natural log of both sides. Of our equation. And if we did so, we get the natural log of y is equal to the natural log of 2 raised to the x power. I'm going to use my properties of logs to rewrite this as natural log of y is equal to x times the natural log of 2. Now I'm going to differentiate both sides of my equation. So the derivative of natural log of y is 1 over y times dy dx is equal to, well, natural log of 2 is just a constant. So I have a constant times x. So the derivative of that constant times x is just that constant, which is the natural log of 2. So let's get dy dx by itself by multiplying both sides of this equation by y. And so we get dy dx equals the natural log of 2 all times y. But y we started with was equal to 2 raised to the x power. So our derivative, dy dx, is equal to, I can rewrite this a little bit. I can bring 2 to the x power in front of my natural log of 2. So we just showed that the derivative of 2 to the x was equal to 2 to the x times natural log of 2 by using logarithmic differentiation.